Welcome everybody to our webinar today about securing containers in the software development lifecycle, where you'll get to learn a little bit about Anchore Enterprise 3.0 and some of the new capabilities and how it can help you with that security and DevSecOps of your software applications. Why don't you go on to the next slide here, Adam? So we're going to do a little bit of housekeeping to get started. You guys are all muted, as you figured out by now. We will be holding a Q&A at the end of the session. So there is a questions panel on the right side in your GoToWebinar control panel that you can use to enter questions at any point during the webinar. And then we'll get to as many of those as we can once we get to the end of the webinar. Also, everybody that attends will be receiving a follow-up email with a link to the recording so that you'll have access and can share that with others in your organization. And once we get to the end of the webinar, there'll be a little quick feedback survey that we'd love it if you could just take a minute or two, or should probably take you no more than a minute to just answer those quick questions so we can get feedback on how we're doing and make adjustments to future webinars. All right, let's move on and talk about the agenda for today. So we're going to just do a little bit of stage setting at the beginning and talk about why you need to secure containers throughout the software development lifecycle. And then we're going to dive into some of the key capabilities of Anchore 3.0 that really help you across the lifecycle, whether you're in the early stages of development all the way through to deployment into Kubernetes, and talk a little bit about some of the key issues that people face in that process around managing false positives and also remediation of the issues that do come up. And then we will have Hayden and Adam provide a demo as well to give you a little bit of a view of the product, and then we'll follow up with the Q&A. So with that, I'm going to hand things off to Adam.
Great. All right. Well, excited to walk you all through our slides and our demo. Supply chain hacks are literally headline news right now. SolarWinds is on everyone's mind, but supply chain hacks are something that has been a common compromise. Even NotPetya, which is officially the most damaging hack, was through a supply chain vulnerability. So first, I want to set the stage. Why is this happening now? And then we'll kind of get into some of the solutions around the problem. So one of the trends that we're seeing accelerate the complexity of software and the software development lifecycle is the adoption of containers. As many of you are probably aware, containers are becoming the de facto way to package your application, and looking ahead, just a few years will be the majority packaging standard for really all of your software. Now, containers are only one aspect of that. Containers are just a piece of digital transformation. Using open source projects, practicing agile, these are all other factors that have increased the complexity of the end result. So your application that's running somewhere in the cloud or in Kubernetes is composed of hundreds, thousands of artifacts that are sourced from, in some cases, vendors, in some cases, open source projects, or some cases, maybe you have those under your private control or developing them yourselves. So thinking about that has really led us to understand that organizations have really built out and adopted a tool chain for managing their software development lifecycle. So this includes that starting step of figuring out what you're going to use to develop your solution, building those components into containers, testing them, and eventually deploying them and running them, primarily in Kubernetes is what we've seen, but in that container packaging. So we're using this framework as a way to kind of think about the problem space. And historically, the problem space has kind of been on the right. So this is kind of the legacy view of what a hack might look like. Your vendor and your runtime has a 0-day, and a hacker is able to exploit that and escalate privilege, and you've been hacked. But what things like SolarWinds have really emphasized is that your entire supply chain is vulnerable to exploitation, and securing that supply chain is really important to your bottom line. We used to think of just, only things happening in runtime were expensive, but hacks like SolarWinds and NotPetya really show that the long-term impact of compromise of your supply chain can be lasting. So, with that, I think we've hit our first polling question to ask a little bit about your software development lifecycle.
Great, thanks, Adam. So we're going to have a couple polling questions as we go through, just to get a sense of the people on the webinar, and so you guys can get a sense of your colleagues that are here. So we're going to start with the first polling question that says, at what stages in the software development lifecycle do you currently include automated security scans or checks for your container-based applications? And so you can pick more than one of these. So check as many of these as apply. And I'm going to give you guys a few seconds here to get your options in. And once you check the boxes, you can go ahead and hit the submit button at the bottom of the question there. All right, we'll give you 3 more seconds to get those in. All right, looking good. Okay, we're going to go ahead and close the poll. And I'm going to share the results with you so you can see how everybody responded. So this is really interesting because if you look at these bars, the early phases of the software development lifecycle have the fewest people doing security scans and checks, and most at the later phases. So this really matches with what Adam was talking about, that historically we've started in the production world or maybe in staging to do our security checks. Now we need to start to shift left, as they say, earlier in that cycle. Back to you, Adam.
Great. WebEx has hijacked my screen here. Hold on a second. All right, so we have logically staged the software development lifecycle really as a way for us to think about the tool chain and integrate with it. So, this is a bit more about how Anchore works. We're getting into the solution space a little bit. And leveraging APIs, leveraging agents, we are able to easily integrate with the various phases of your software development lifecycle. We have the sort of scalable approach to analyzing the software at each of those stages. And then we have a consistent policy language that you can use to feed into both a notification-based API and a reporting or schedule-based API, which we'll kind of highlight in the demo as ways to integrate into your tool chain. So one of the areas and challenges that we see security teams really facing is how to triage issues, how to route them, and usually the security team is dealing with a number of different engineering and operations teams, and each one of those may have a specific tool that they prefer. So we're going to walk through that a little bit in the demo and highlight how we can integrate with those tools and guide you through that workflow. And I think that leads us to our next polling question related to vulnerabilities.
Yes, so remediation. So when you're doing your scans and your security checks, one of the things that you're finding and uncovering is vulnerabilities, and you probably have some challenges associated with those. So here you can select as many of these as are relevant in your organization. So whether your challenges are determining which ones need to be fixed, determining which vulnerabilities have fixes, the length of time that it takes to remediate, getting developers to focus on remediation. Some may not prefer that as their main task, and other are not sure if you don't know. Let me give you a couple of seconds to get your answers in, and you can hit the submit button once you've made all of your selections. And we'll go ahead here and close the poll and share the results with you. So probably not a huge surprise is 75% of you are saying getting developers to focus on remediation. I think by their nature, developers, and probably many of you on the call are developers, you'd prefer to be building new features and capabilities, and maybe fixing vulnerabilities isn't your favorite thing to do. The second is really determining which vulnerabilities need to be remediated. And then you can see a fewer number about determining which ones have fixes or the length of time. So with that, back to you, Adam.
Great. So as I mentioned, kind of knowing what to do, who to assign it to, get those developers' attentions. I think the poll kind of highlighted some of those things. That's something we're going to really walk through with something we call action plans in the demo. So I'll be jumping into that in a few minutes. And we have another polling question. Over to you, Kim.
All right, final polling question. How much of an issue are false positives in scanning for container vulnerabilities? So i.e. finding vulnerabilities that either don't apply or aren't maybe critical to fix in your environment. So this one, you just get to pick which one of these options, the one that you think is the level that best describes how important it is in your organization. I'll give you a few more seconds there to pick your option, and then don't forget to hit the submit button once you've got the option selected. All right, we'll go ahead and close the poll and share the results. So by far, the biggest number of you said it was a significant issue, and this really maps to what we hear when we talk to customers. One of the interesting quotes I heard somebody say was, it's not that developers don't like to fix vulnerabilities, it's they don't like having to look at the overwhelming number of vulnerabilities that aren't really relevant or important to fix. And so they really want to spend their efforts on the focused areas. So why don't you talk a little bit about false positives, Adam?
Great. So hop back into my slides here. Yeah, false positives are definitely something that we see security teams struggle with. I think back to the scope of complexity, it's important to remember a centralized security team might be dealing with hundreds, thousands of containers, each of those having multiple vulnerabilities that quickly scales into thousands of vulnerabilities. So being able to manage the volume that you're seeing and really sift out the best signal is something that is important in the toolchain you choose related to security. We accomplish this really first by being very deterministic about what's in the software, being able to both look at what's running as well as what's in the container is something that we are really best in class at. And we use that to match to specific vendor feeds. So if we see a piece of software comes from Red Hat, we match that with the corresponding Red Hat feed. So our automated approach gets us the best signal we can, but we also have tools for users to apply corrections if they see something is misidentified, or allow certain CVEs if they're waiting on a fix from a developer or from the vendor themselves. So that really allows you to build out automation that you can enforce through policy and really secure that supply chain. So one of the ways we do this is by taking an API first approach to our software. Whenever we design a new feature, we think about the API that either a tool is going to be interacting with, or eventually our own CLI and UI is kind of our opinionated version of those APIs. But everything that we create, we sort of build out as an API first, and then we let the community develop tools for CI/CD systems, registries, runtime, and we'll see some of the kind of collaboration tools that we tie into as well with the action plans. So let me hop over. We're going to start the demo. So I'm going to start the demo by putting on the role of a security team. So I work on the centralized security team, and we have an app that we're monitoring. I know we're doing some software development on it, and we're running this master image. It was last analyzed a month ago, but I can see it's running in my cluster. What I'm worried about is we made lots of new hires this year. Not everyone is really up to speed on our security policies. So I saw this tag rebase come up, and I was a little worried because that could violate some of our policies. So I'm going to jump into this particular image and see what's going on. And right away, kind of a lot of red on the screen, and I know some of you aren't familiar with the product, but as someone familiar with the product, I'm instantly worried because I see CVEs jumping out at me. I see things that are on our deny list being used. So I want to look further into what's going on with this particular image. So we have a concept of this change log, and this is analyzing that software bill of materials I mentioned. So I can see that this image has changed its OS base version from Debian to Ubuntu, and that's something I, as the security team, really care about. I know our developer doesn't really care. He probably just cloned some project and it's using Ubuntu. There's more layers over in this new image. I really don't know why the developer's chosen to do that. So I'm gonna jump back over to my compliance view here, and the compliance view is really breaking down all the policy violations for me. So when I mentioned the guided aspect, this is an important part of that. And you'll see, I have already a recommendation to change some things in the Docker file, and I'm going to add a note here to use updated Ubuntu base image. And I'm going to add that to what we call our action workbench. So, that's one of the things I'm going to add, and I'm also going to call out this wget. And put those into our action plan. So once I have this assembled, I know where I'm going to reach out. So in this particular case, Hayden's team uses Slack as their communication platform. So I'm going to go ahead and put that in a Slack, send that over to our developer, Hayden, and I'm going to send it over to Hayden.
Sweet. Thanks, Adam. All right. So now I can go ahead and pick up where Adam left off, right? So I can go ahead and open up Slack and see what Adam had gone ahead and sent me, right? So here, I am a new hire, right? So I went ahead and branched off that master branch, which is where we're tracking our production application. So I, created a rebase branch, and I see that Adam sent over a couple of remediation actions for me to take, right? So I need to go ahead, remove health check, which I've already gone ahead and done. And then I see some packages in here, which I can do by removing this install command, which I've already gone ahead and done. So I'm going to go ahead and push those changes to my repo. And what that will do is trigger my pipeline all over again. So when Adam is talking about, hey, working with different tools and integrations as a developer, right? I don't need to worry about if scanning is going to work, if it's going to fire properly. I know it is because I have it integrated into my GitLab project here, right? So I have that rebase branch. So if I refresh this, we should see that build occurring in our pipeline, right? And all that's easily configurable using the CI.YAML file that GitLab provides, and just a few easy steps that integrate these Anchore CLI commands, which help interact with the Anchore API. So as a part of every build that my developers are doing, that I'm doing on my team, the cowboy coder, right, that's out there doing whatever he wants, Anchore sits in the background waiting for that developer to push, right? So on every push, we do that analysis. So and as a part of that reanalysis, we're giving that full CVE compliance list, a full evaluation of the SBOM and things like that. So we could go and see kind of what's going on in this pipeline, right? So if we go back here, we'll go to rebase, pop over, it's probably still building. It's running the Anchore scan as we speak. So if we pop over here, we can, while that's scanning, right, we should be able to refresh and see that, okay, it's analyzing, it's doing its thing. While we're waiting for that to kind of complete, we could take a deeper dive into looking at, really what the policy generated and why it generated those failures, right? So Adam already talked about, the change log, which is really important. So you could see that I went ahead and added additional layers, but taking it a little bit deeper, he could actually see that I went ahead and added specific packages, right? So if we look at libssl, I went ahead and added that. And I went ahead and added wget for maybe some troubleshooting or something like that, which were both unallowed, right? So when we see this new image that has been scanned, if we did it successfully, we should see those packages have been removed. And this talks about, this really highlights having the data available, providing transparency and ownership to both developers and security. So at any time they can query, what exactly is in that software bill of materials, and it helps, easily integrate and automate that process into the software supply chain. So let's go back. Let's see if that has actually completed. Do a quick refresh. Hopefully it finishes up here. So yeah, it has. So we could see it completed a minute ago. Let's pull up those results. Let's go back to that change log. Okay, perfect, right? So we could see that I put it back on our approved base image. After getting that message from Adam, I saw a lot of those vulnerabilities were actually linked to the base image itself. So the OS related stuff. So I went ahead and switched it back, really slimmed down that image, not very many layers left. Went ahead and removed those packages. So if we now highlight on what has been removed from there, we should see, wget was removed and the CPEs against that. Also, we can see, make sure that libssl dev package was removed. So we went ahead and removed that. If you wanted to look and even go deeper into the SBOM, that's where the contents tab comes into play, right? So you could really filter, on stuff that's related, totally unrelated to the packages, but even going down to the files, right? So seeing specific permissions that are being set on files, the size of those files, where that file lives. So you could go ahead and take it a little bit deeper there. And also, I think one of the unspoken heroes of our contents tab, or unsung heroes, is the malware scanning, right? So as a part of Anchore, we already do malware scanning in all your builds. So anytime that image does a build, it does a malware scan, and if malware was detected, it would show you that location and signature of that, which is really useful. But let's go back and look at our policy compliance here. So policy compliance tab is really going to give you that evaluation. So if we look here, we can see we passed that result. And to make sure everything's lining up right, we should be able to go back here and back to what our developer is seeing, and he should see that, or she should see that, right? Which is, yeah, we went ahead and passed. This is good. It ran against this policy. There's still some vulnerabilities, but not very many. And that's what we should see here. So if we open up our whitelisted CVEs, what we should see, is that, in fact, Adam has already approved these CVEs. So maybe there's not a fix available yet, or there's not, a patch out for us to remediate these CVEs, or maybe the security office has just approved the risk associated with these. So, that's another really good granular control that Anchore provides. So it's not getting in my way as the developer, right? If there's CVEs out there that your org has already approved or already, incorporates as a part of the risk modeling, it's really important to be able to track that. So that way it's not standing in my way. Because the last thing you want is for me to go into that GitLab CI file and start disabling the scanning altogether because I think it's worthless, right? No, that's not what Anchore does, right? It really empowers that security team and empowers the developer to incorporate the security and feedback from that into their best practices, right? Going back and taking it a level deeper on the policy approach, right? If we go here to the default bundle, the policy bundles tab is what really controls the scanning profile that is used during your supply chain, when you're scanning and incorporating, all those security and compliance results into scanning your container images. So the scanning policy will definitely serve as the backbone for that. So if we go in and look at how Adam created those policy rules, we can actually see here that he went and made a blocked packages policy, which is really easy to do. So right here we can see he has that lib SSL dev package, wget tcp dump, nmap. So he made that by just using the gates here within policy. So being able, to control what packages are being installed on your system, you can really provide ownership over that SBOM, right? So creating an allow and deny list for packages, which is something commonly used for ports, right? So having an allow list and deny list for network traffic and for traffic within your clusters and stuff, that's an information security best practice. What's also an information security best practice is doing that same thing except with software packages. So that's what Anchore is providing right here. So having that here, you can do a required package that maybe every dev is supposed to have. You could do a deny list, which is what Adam did, right? So he added one here. We could just add another one just for the sake of demo, and we'll just save that. And then if we look at the overall policies that were just available by default, right, we could see that from check. So we're checking the Docker file to make sure that it's pulling and incorporating the Debian stable image. So for the purposes of this demo, right, we were saying, this developer should only be building from Debian stable, and we want to monitor for anything that's a deviation from that. So that's what this is doing. But you can take this a million different ways. So having the ability to tailor your policy, to your organization's specific requirements is really what Anchore provides here in the policy creation tab. So here you have the ability to monitor for any command that's being run in your Docker file, right? So I was monitoring the from command, right? The first command you would use in a Docker file. Doesn't matter if you're using Docker build, podman, whatever. You can scan for specific files. So again, when we were talking about providing ownership over the SBOM, monitoring the SBOM, you can monitor for changes being made to files, checking specific modes being set on files, which is really useful. Let's see, another really good creative gate that we see people like Adam using on the security side of the house would be our vulnerabilities package gate. And this is one that's really important when we consider creating temporary allow lists. So say a CVE is published, but there isn't a fix available yet. It's not really fair to start failing your developers' builds if there's no patch available for that CVE yet. Maybe you want to give them a time period to go ahead and remediate that. And then after that time period, you're going to start failing those builds because maybe there is a fix available now. But really, the vulnerabilities tab has so many different selectors that you could go ahead and create a baseline for your organization here, to whatever that baseline needs to be. Some organizations rely heavily on CVSS v3 base scoring. You could filter if there's a patch available or if it isn't available. All that's available to you right here. So you could, say, I only want to worry about, anything greater than or equal to a medium that has a patch available, right? And you could go ahead and save that. And then let's say, a base score higher than a 5. And then you can now make that as a part of your policy. And it will then alert you, if those criteria are met. And we see that health check instruction pop up again. But really, it's all about creating a policy that meets your organization's needs. And at Anchore, we believe, whatever your organization's needs, whatever compliance or security needs that you have, Anchore is here to kind of meet that. That's what the policy bundle and policy scanning is all about, right? So if we were to look at, providing that allow list that I briefly mentioned, and we saw it earlier in the policy compliance tab, what we would see here is that Adam went ahead and entered those CVEs as saying, hey, we bought off on this package, and we set an expiration date right here in the Anchore UI. So we went ahead and said, hey, these CVEs are okay. We're not going to fail builds based on these CVEs, right? And we're going to set that expiration for the end of the month. So we're going to give everyone till the end of the month to kind of remediate this. We'll reevaluate it, whatever. But that's really what's important here, is really having that temporary allow list to not get in your developer's way. And then extending that right into the Kubernetes runtime is really important. So right now, up to this point, we have talked about really what the feedback loop and remediation workflow is between maybe a traditional security personnel and a developer, right? What we're going to be taking a look at here shortly is really going to be looking at, okay, now that that image has successfully run, it's been passed, it's been approved, and if we look back at our pipeline here, we can go and see that hopefully it's pushed a new tag that we could then, so this pipeline passed, right? So we can then merge this branch into master, and it can go through its life cycle and deploy out and live and run on Kubernetes as any healthy web app would want to do. But for us, we want to be able to monitor for vulnerabilities in our runtime, right? In our runtime environment. So Anchore provides the ability to do that. So here, what I'm doing is using one of our report templates. So you don't have to make a format or anything to do any of this reporting. It's all available out of the box to you, and it's also all available over the API. So if you hate this, you can easily use the API to do these same functions. So here I'm going to be spitting out a report that's filtered on the vulnerability criteria that our org has. So I could say, I only want to see the runtime vulns that are high, critical, and medium. So I could preview a report and see just that, right? So I could see the runtime context. So I could see, where they are. And then from here, I could filter on, my application that I was concerned about, that me and Adam, or Adam and I were working on, right? So I could see the my app namespace, and I can actually see, okay, cool, those CVEs line up with what I just saw in my allow list, right? So now I have like peace of mind knowing, when I'm looking at those images that are out there running in Anchore or running in my cluster, I could map those back and know that there's no vulnerabilities, that haven't been scanned with Anchore out there in this context. Which is really nice. But, like I said, it's not just about, vulnerabilities. It's also about compliance too. So having a good policy in place and being able to see images that failure policy is also another reporting template that is available in Anchore for your security teams and for your developers to query at any time. But, you have the ability to configure this to automatically run. So basically, you just set this and forget it, right? And from here, you can see all your images that are failing against a specific policy, which is really powerful. But we understand these are large enterprises, right? So you may not want to just get every image that's ever failed a policy, right? You may want to filter this on a specific repo, say our GitLab repo we were just working out of. A specific registry or a specific tag, right? So really extending this policy and CVE evaluation, not just during that build phase, but providing that reach to go a little bit deeper into the runtime space is something that we're providing here with Anchore 3.0, and having that ability to track those false positives and track those CVEs that have been placed on that allow list throughout the life cycle is something that's really powerful that we see here with Anchore, and hopefully that came across here in the demo as well, and along with the awesome remediation workflow that Adam and I have walked through. With that, I'm gonna actually turn it back over to Adam, I believe.
Hi, Hayden. Adam, if you want to get your webcam back on as well, we're going to go ahead and take a few questions that have come in. And for those of you that have questions that haven't asked them yet, feel free to go to the Windows, the GoToWebinar control panel. So the first question we have is there support for Windows Server Core container scanning?
Yeah, so we do have support for Windows scanning. I don't know specifically what Windows Container Core is. I suspect, I don't know if that includes
Server Core, Windows Server
Windows
Core.
Server Core. So
Yeah.
yeah, I think that includes IIS, and we have feeds that should have vulnerabilities related to IIS. So I think the answer is yes. Broadly, we support Windows. It's one of the things that people do choose our enterprise product for. So we have good Windows support. I suspect we cover that specific stack as well.
Great. Okay, we have another question, and I don't know if I'm pronouncing this right, but it says RHEL likes the idea of moving toward utilities like Builda. I don't know if it's Builda or Build-AH, how you pronounce that. Do some of these same policies check in a Builda container generated without a Docker file?
Yeah, we support the inspection and scanning of containers built without a Docker file. We're believers in that approach. We think it has inherent automation approaches. So the way we do the SBOM generation is to inspect each of the layers regardless of how they're built. Docker files give us, well, both give us different opportunities for automation. So we see more systems coming online that don't use Docker files. That's a trend. And we do accommodate those. But it really, whichever way you decide to build your container, we can inspect and serve security results for it.
Great. The other question, do you have a capability to do runtime checks in a sandbox before releasing to deploy?
That is a common application we see of our current runtime capabilities. So we kind of have two offerings in the runtime space. One is an admission controller, which prevents something from running in your cluster based on a policy result. So that's sometimes thought of as, I'll gate production. I won't let anything into this environment because I'm running the admission controller. But we also do inventory. So you can take the inventory of a cluster you're using for sandboxing purposes, and whenever something shows up there, run a scan on it. So it's a little bit up to you to architect your own sandbox, but we provide the tools that should allow you to treat one environment differently from another and still leverage our policy and automation.
Okay, great. We have a question from Frank that we have multiple offline networks. Can I take remediation steps such as ignore false positive, et cetera, and export from one system to import into another? So I think they mean share across sort of detached networks.
Yeah, certainly. That's something that we've seen a lot in our public sector team. So a lot on the federal side, we're dealing with mission sensitive customers who have that same goal, right? So what your example is talking about right here, Frank, is actually dealing with something that we would see in a policy object, and that policy object ships as a JSON file. So as long as you're able to import that same JSON file across different environments, or if you have the same Anchore deployment, say in the classified or air gap space, and that's it, synced with the other kind of workers out there, you could have that centralized policy to kind of serve across multiple deployments on that, air gapped environment.
Perfect. Thanks, Hayden. All right, I think that's the last question that we have. So thank you everybody for joining us today. We will keep an eye out for our future webinars on a variety of topics related to containers and security and compliance, and we hope to see you again soon.
Thanks all.
Thanks everyone.